Several researchers found a measured redshift periodicity in QSOs in spiral galaxies. Here are some, and more. The scalar theory of everything includes a model for galaxy redshift. You may visit the YouTube video John Hodge Stowe redshift. This video suggests the discrete variation in redshift are consistent with the stoe. Indeed, the stoe explains the discrete variation. Stowe suggests plenum density is changed by the presence of sources and sinks. The changed plenum from a 1 over radius from us changes the redshift measurement from the Hubble law. The changed plenum density changes the redshift. Plot the scalar potential density versus distance. This is a graph that appeared in the previous video. You see, here's the 1 over r relation, which would give the Hubble law, but there is a sink and some sources close to our line of sight, so the plenum density is modified from the Hubble law. The z measurements are kind of clumped, and that clumping is not confirmed by the distance measurement. A is arc degrees from NGC 5353. The filled diamonds are sink galaxies. The open diamonds are source galaxies. Filled squares are distances determined by the Tully-Fisher method and others by the open squares. Now, you'll note over here we have a sink galaxy and a couple others more or less here. And the other galaxies seem to be pretty much on a line at a constant z from us. This is not confirmed by the distance measurements. So those galaxies that are positioned closer to us than these sink galaxies will have their redshift increased. Those galaxies, like up in here, that have the sink galaxies close to the line of sight will have their redshift decreased, thus forming what looks like a discrete wall. Here's another example up there. This is another example, NGC 2636, and you see the same thing. Here are the sink galaxies, and there is the discrete variation, which is not confirmed by the distances. The reference paper had 7 other examples in different constellations. The Stowe model of redshift suggests the major reason for galaxy redshift of photons is dependent on the plenum through which the photon passes. The plenum density is changed by sources and sinks, that is, say, spiral galaxies and elliptical galaxies. Therefore, the redshift measurement is clumped if the sinks are close to the line of sight. No other model provides an explanation of discrete redshift. This is the paper that talks about both redshift and discrete redshift. You can search for other topics, John Hodge, Stowe, plus whatever the title is, such as redshift.